My name is Sanfika Chakoti, and today I present to you VocalLearn. As a singer myself, I understand that countless communities worldwide are filled with aspiring musicians and singers. However, in the status quo, access to professional music and singing lessons is limited for low to middle income populations. Without the tools to succeed, like access to music education or vocal lessons, they are often forced to abandon their dreams. Vocal lessons and music education may be expensive, but they should be accessible to all people, regardless of wealth or class. Here are some statistics on the matter, as per the National Arts Education Status Report Summary in 2019. First, as you can see, as the population of students in a student body who requires free or reduced price meals increases, that same student body population that lacks music education also increases. Location plays a factor as well. Those who live in cities, towns, or rural areas disproportionately lack music education. Last, race plays a huge factor. Those schools with a large population of Native American students also disproportionately lack music education. Overall, around 3.6 million students in US public schools do not have access to music education. Well, the solution? VocalLearn. VocalLearn endeavors to bridge disparities in vocal education by correcting users' pitch and suggesting specific vocal activities for each user based upon data collected from the user's vocal history over time. VocalLearn differentiates itself from similar teaching apps because of its ability to collect the strengths and weaknesses of each specific user and suggest specific exercises. This personalized approach makes VocalLearn most similar and akin to an in-person vocal teacher, as vocal teachers understand the specific nuances and areas of improvement for each singer and suggest specific practice mechanisms, exactly what VocalLearn does. Now, here's how I approached this project. First, I located the instance dataset on Kaggle, which contains large musical data of different instruments playing varying notes. It's essentially a collection of wave files. I focused specifically on the vocal files within this dataset. The initial code that I wrote takes the user inputs and returns if the user is singing sharp, flat, or on pitch, comparing it to the vocal recordings in the dataset. After enough data is collected on the user, VocalLearn will provide specific solutions for each user's problem areas based upon some samples of the user singing. Now, my project required a lot of knowledge of different data types. Pictured here is the instance data set. The notes or the note wave files are categorical or qualitative nominal data, since it's audio recordings with named pitches. When I converted notes to frequencies, or I set the pitch accuracy of a user, that's numerical continuous data. The duration of an audio, like the length that a user sustains a note for, that's numerical continuous data. And the user's skill level for when they progress on their vocal journey, that's categorical ordinal data because the labels have an implied order to them. The data set that instance was structured, and it had labels for each instrument, and it was also organized into potential training and testing splits. However, despite this organization, I did face some initial struggles. First, the large dataset was difficult to navigate, as it contained data from a plethora of instruments, including piano, bass guitar, acoustic guitar, vocal, etc., etc. So I had to specifically extract vocal data. Moreover, it was my first time handling audio or musical data, and it was a little bit difficult, as it required some knowledge of frequencies and music theory. So to handle this issue, I learned how to navigate the Librosa library for audio files so that I could easily handle them with Python. Now, here are the techniques that VocalLearn will use. First, pitch accuracy classification. Now, this isn't just telling the user if they're going to sing sharp, flat, or on pitch. It's also predicting if a user is likely to hit a note correctly based on their past data. This will use a logistic regression model within scikit-learn library. This will encode the notes as numbers and account for the various factors that could influence their singing. Next, user clustering. This will group users based upon their specific pitch performance or pitch struggles. And this would use the k-means and dbScan libraries from scikit-learn library to create clusters and handle outliers of those clusters. This connects directly to my next feature, exercise recommendations. This determines which exercises will assist each user best. Now, in beta versions of VocalLearn, we'll have preset rules based upon parameters, like if a user scores above 70% on pitch accuracy, they'll be assigned blank exercise. However, in advanced versions, we'll use K-nearest neighbors from scikit-learn library to compare users with similar issues to similar vocal exercises. Last, we'll utilize progress prediction, which can help a user forecast how their pitch accuracy will improve over time using VocalLearn. This would utilize a linear regression model from scikit-learn library. Now I have an initial version demo. So essentially, I used Google Colab to create my initial version demo because of its file upload functionality. However, the code is pretty applicable to Jupyter Notebooks as well, except for that one feature. So essentially what I'm going to do in this demo is I'm going to upload an audio file of me singing a note, D4, and it's initially going to be an audio file of me singing the note on pitch, and this is just going to play the note back to you. And so as you can see, I'm singing the note on pitch in this file, and now it's going to estimate the frequency of the pitch, and then it's going to see which note I'm singing close to. So my closest note is D4, which is correct, and it's saying I'm 0 cents flat, which is telling me that I'm on pitch. Now I can show you that this works for when I'm singing flat as well. So I'm going to upload a file of me singing the same note but flat. So D4, but singing it flat. Give me a second. So you can see I'm uploading it. And now it's going to play it back for me. So as you can hear, that doesn't sound as great because I'm singing it flat. And it's going to estimate the frequency, and now it's going to see if the closest note is. It's D4. However, this time I'm singing the note flat. Now, obviously that version is way simpler than what my final version is going to be. So in my current version of the code, VocalLearn simply focuses on extracting an estimated frequency from an audio and determining if it's flat, sharp, or on pitch. However, once VocalLearn implements the aforementioned features, its uses are boundless. VocalLearn can have profound impacts on music education for underprivileged communities, allowing for their dreams to become a reality. Moreover, for those afraid to start their vocal journey, VocalLearn will become their personal guide. With personalized recommendations that simulate a vocal teacher's instruction, anyone, from the comfort of their homes or in classrooms for free, can become a singer. Thank you so much. Do you have any questions?